A ball is thrown horizontally from a height of 10 meter with a velocity of 21 meter per second. How far off will it hit the ground and with what velocity? So let's understand the question first. So suppose this is ground and here the height is 10 meter. So someone throws a ball horizontally with a velocity 21 meter per second. So as a result, we know that the initially ball will go straight, but then because gravity will work on it, so it will follow a path something like that. So we need to find how far off will it hit the ground. So just imagine that the ball started its journey from this edge to have a good reference. So we need to find this distance x. And then we need to find that with what velocity it will hit the ground. Because when it will hit the ground, it will have certain velocity. So we need to find this velocity v. So let's give a proper names to the variable so that we will understand it very well. So this is height h. So this is an example of a motion in two dimensions because body is moving horizontally and vertically. Because it is falling down and it is also covering horizontal distance. So you will see that it will fall down to the ground after covering certain horizontal displacement x. And I discussed it in detail in my lectures about projectile motion, that whenever you have a motion in two dimensions like this, you can split the problem into two sections because these two motions are totally independent of each other and they have no influence on each other. So you can consider them as two separate motions. So one should be vertical and other should be horizontal. And the good thing is that you can divide the velocity. So when you are dealing with the vertical velocity, always take the vertical component of velocity. So if we consider that v of y or y component of a velocity is the vertical, so v of y, and if you are dealing with the horizontal part, always take horizontal part of the velocity. And then you can solve two parts totally independent of each other. When you are dealing with the vertical motion, always take equations of motion for the motion under the effect of gravity, and we are familiar with them. The three equations of motion when a body is undergoing the acceleration due to gravity. And for the horizontal, it's quite simple because we know that the horizontal distance x equals velocity times t. This is the only formula we have if velocity is constant. And I told you that in such situation, the horizontal component of the velocity remains constant. So let's solve this question. Okay, so because now the motion is in two dimensions, we need to consider the two components of the velocity. So let's say what is the direction of this velocity. They said that a ball is thrown horizontally. So it means this is the horizontal component of the velocity because velocity is purely horizontal. So let me give it a name. We can call it Vix. Usually we take x component of a vector horizontal. So let's call it Vix, initial velocity along the horizontal axis or x-axis. We just take x-axis as horizontal, and let's consider the vertical axis as y-axis. So according to this reference frame, we can call it Vix equals 21 meter per second, and it is purely horizontal. So then we need to find what is v of y or vi of y, the initial velocity's y component, what it should be. Can you tell me? It should be 0 because the ball was thrown horizontally, so there was no vertical component of the velocity. Velocity is purely horizontal. However, because they also told us to find the velocity with which it will hit the ground, and see that this velocity, it will hit the ground. When it will go to hit the ground, the velocity will be slanted, so it will have a vertical. For example, the velocity is like this, so it will have a vertical component and also horizontal component. So if this is the final velocity Vf, so this is Vfy and this is Vfx, x component of this final velocity with which it will hit the ground, and this is the vertical or y component of the final velocity with which it will hit the ground. So we have to find both components if we want to find this velocity with which it will hit the ground, because it will not fall down vertically like this, so that velocity has only y component. It is slanted, so if it is slanted, it will have two components. So just remember those things, rest is just simple calculations. Okay, so let's find the how far off will it hit the ground. So let's calculate this thing first. We need to find this distance x, and then we will go for. Okay, to find this horizontal displacement, we will only take the horizontal part of the velocity, because only horizontal velocity is responsible for the horizontal displacement of the object. Vertical component of the velocity has no role in that motion. And I told you that in such motion, the horizontal velocity is constant, and if velocity is constant, we can easily find this displacement x equals Vix multiplied by t. If you remember, I wrote this formula here. This is just for one-dimensional motion. If there are two-dimensional, then you have to mention it explicitly that this velocity is only the horizontal component of the velocity, because the displacement is along the horizontal dimension, and of course the velocity and the horizontal displacement should be along the same direction. So x equals V I of x into t, and it's easy, right? Because the initial velocity with which the ball was thrown is purely horizontal velocity. It's Vi of x, so we know the velocity, but we don't know the time t. What should we do to find the time t? Because without time t, we can't find the horizontal displacement x. Okay, so I also discussed this fact that, for example, in the projectile motion, that whenever a body goes a motion in two dimensions, so the time it takes for the object to reach this point, for suppose from point, so the time it takes for the body to reach from A to B, this time t is equal to the time for the body to reach at the maximum height. Suppose this time is t1, and then for the time it takes for the body from the maximum height to reach the ground, if it is time t2. So this time it will take for the body from point A to B. If it is t, this t equals t1 plus t2. So that was a projectile motion, and in projectile motion a body reaches at a maximum height and then it goes back to Earth. But in our problem, the body is already at certain height, maximum height, and it just comes down to the ground. So it means the time it takes for the body from starting of the journey to the very end of the journey, this time t should be equal to the time it takes for the body from the maximum height to hit the ground. So I am showing this in one dimension, but actually it hits the ground at the final point. So this time should be equal to the time for the body to cover a distance x. So it means I can use equations of motion to find the time t, and then later on I can use this time t to find the horizontal displacement x. So let's find time t. To find time t, we already know the height, and we know, okay, and because this is vertical motion, so always remember to take the velocity viy always 0. So don't use 21 meter per second, because that is horizontal velocity, and horizontal velocity is only responsible for the horizontal displacement of the body. It has no role in the vertical motion of the body. So now, because we are calculating the time considering only the vertical motion of the body, so, and luckily we know that this time t to cover this height is equal to that time, so we can use this time later to calculate the x. But we are calculating the time considering only the vertical motion of the body, and for the vertical motion of the body, initially viy is equal to 0, because the velocity given to the ball was purely horizontal. So always take, wherever you need to find the initial velocity, you need to put the value of initial velocity, always take that 0, because we are calculating the time considering only the vertical motion of the body, and we will take height as 10 meter per second. Okay, to solve this part, we can consider that a body was initially as at rest, viy is equal to 0, and then suddenly it was dropped and it hit the ground, and we know that the height was 10 meter, and we want to find the time it will take for the body from the maximum height to the ground, because we can simplify that two-dimensional motion into a one-dimensional vertical motion, because we want to calculate the time t it will take for the body from the maximum height to the ground. So I know that I have equations of motion. If the motion is under the effect of gravity, for example, 2gh equals vf squared minus vi squared, or if I use the notation I am using, it should be v and vf of y. Because if we are dealing only with the vertical motion for some problem and there is no other motion involved, we usually represent these velocities as v, because we already know that velocities are vertical. But in this problem, because the motion is in two dimensions, so we need to define that if it is the vertical component of the velocity or the horizontal component of the velocity. So if I use the same notation, I will write the velocities like that. So final velocity in the y direction, final velocity in the the final velocity and the initial velocity in the y dimension. So I can't use this equation because I want to find time t, and there is no time t in this equation. Another equation is vf of y equals vi of y minus gt. I can use this equation, but the problem is I don't know the final velocity with which it will hit the ground. You see, when it will hit the ground, I need to have this velocity vf of y, and I don't have this velocity right now. So let's see if another equation can solve this problem. So h equals VIYT plus half GT squared. I use as a positive term, and before I use negative actually, but it should be positive because it's very customary. If a body is falling down to the earth, we take G as positive, and if a body is going upward against the force of gravity, we take G as negative, because in our problem the body is falling down to the earth, so we should use positive G. H is equal to VIYT. Okay, so here we only need velocity VI, which we know it's 0, and then height and time. Yes, so we can use this equation to find time t. So let's do it. So height h is 10 meters. So 10 meters. So VIY is equal to 0. So this whole term will just cancel out. 1 by 2. 9.8 meter per second squared into t squared. So t squared is equal to 10 meter, and I will take this 2 to the other side, so it will be multiplied, and I will divide the equation with 9.8 meter per second squared, and t squared is equal to 2.04 second squared. Then next I will take the square root, and I can find t equals 1.43 seconds. Okay, so I found the time t, and as we discussed before, that even for a projectile motion or a motion in 2 dimensions we have here, this time t should be equal to the time t it will take for the body from the initial point to the final point. So this time t is equal. It means we can plug in this time into this equation to find the horizontal displacement which is what they are asking us to calculate. So let's calculate x, and remember, when you are calculating x, now you will use the horizontal component of the velocity, so don't confuse them. So x equals vixt, the vix, the horizontal component of the velocity, it is 21 meter per second. So 21 meter per second multiplied by with the time t it will take for the body from this point to this point, and this time t is equal to the time it will take for the body from the initial or the initial point to hit the ground, and we have calculated this time down here. It's 1.43 second, so I am inserting this value here, 1.43 seconds, and this horizontal displacement is equal to 30 meters. Okay, so we have solved the first part of the question. I have cleaned all the mess. I apologize for the mess I made on the whiteboard, because purpose of my videos is not to give you a mere solution of the question. I want to give you as much information as possible to understand the question and think logically. And I also want to give you the techniques how to tackle a problem and how to find the unknown variables, and also all the related concepts and the theory if possible. Okay, so now we will move to the second part of the question, which says that we need to find the velocity with which the ball will hit the ground here. And I told you that this final velocity is not purely horizontal or vertical, it is slanted, and you need to find the vertical as well as the horizontal component of this velocity to find the total Vf with which it will hit the ground. So let's find the vertical component of the velocity, because it is simple. It involves only the vertical component of the velocity, and it's simple. We already have the equations of motion for a body moving under the effect of gravity, and you can use any of these equations because we already know all the parameters. For example, I can use the first one, or I can use the second, third, I can use any one of them. So I will just choose the first one. Okay, so 2gh equals vf of y squared minus vi of y squared, and we know that this viy, the initial vertical velocity, is 0 because it was purely horizontal with which the ball was thrown. So it is 0, and we need to find vf of y, the vertical component of the velocity with which it will hit the ground. And remember, this is not the final velocity with which it will hit the ground. Final velocity is slanted, and we are only finding the vertical component of this velocity, vf of y. So if this is the ground and this is vf, the final velocity with which it will hit the ground, and we are only finding the one piece. So another missing piece is the horizontal component v and vfx. So this one is missing, and we will deal with it later. Okay, so first let's calculate the vfy. So this one is 0, viy squared. So I am going very quickly. Vfy squared equals 2gh, and because we want to find only vfy, not its squared, so 2gh under square root, and I am inserting the values 9.8 meter per second, and then we need to give the height. And if you remember, height was given, the ball was thrown horizontally at a height of 10 meters, so it was total 10 meter. We know this quantity, so just put it there, 10 meter, and my calculator tells me that this value is 14 meter per second. So now we found the vertical component of the final velocity with which it will hit the ground, and now we need to find the horizontal component because this is the missing piece of information. So let's see how can we find this information. So we need to find v f of x, the horizontal. So do you have any idea how can we find this vf of x? If you remember, I told you initially that the horizontal component of the velocity will remain constant throughout the motion of the body, and that's why we use this formula, x equals vixt, mean the horizontal component of the velocity times t. This is a simple formula if the velocity is constant. If horizontal velocity is constant, it means if initially it was 21 meter per second, it should remain the same because it was constant, right? It didn't change throughout the motion of this ball. So now we know we have already found vf of y and we have found vf of x. So let's write the final velocity with which it will hit the ground. So v of f equals, if you know the vector notation, we need to write the I and j components. So I mean the horizontal component, and it's 21 meter, and vf of y is 14 meter. So this is the final velocity with which it will hit the ground. And I just want to point out one more thing, because usually it's up to you and it doesn't matter, that usually if for a reference frame, if a quantity is upward, we usually take it positive, right? For example, vf of y. And if it is downward below this x-axis, or in our case it is ground, then usually we take it vf of y. You know that if the quantity is below x-axis, we take y as negative. So I suggest to use a negative sign here instead of a positive. So 21 negative 14, but it's up to you because it depends how you take the direction. And if you want to find the magnitude of this velocity vf, and we represent it usually this, or sometimes we use double bars, we know that this is the vf of x squared plus vi of y squared. And if we put these values, Vf of x is 21 meters plus v of y is negative 14 meter. Just if you take the direction according to my scheme, 14 and square root, and my calculator tells me that this value is 25 meter per second. Let's try to understand this question with the help of animation. So as you remember, question says a ball is thrown horizontally from a height of 10 meter with a velocity of 21 meter per second, and ball is thrown horizontally. So here is the animation, and you remember I used it to explain projectile motion before, and because in this example which we are solving, or which we have solved, is a motion in 2 dimensions, so we can still use this animation. So the ball was thrown from a height of 10 meter. So let me raise the height to 10 meters, and because the ball was thrown horizontally, so I have to make this angle 0. So now whatever is the velocity of the ball, it will be purely horizontal, and the velocity is already 21 meter per second, so it's all right. And in the question it is a ball, but here we have a cannon, it doesn't matter, motion is same. So let me go back to the question, and the horizontal velocity was 21 meter per second. Okay, so and we needed to find the horizontal displacement from the starting to the very end where it will hit the ground. And if you remember, we found that distance x is 30 meters. So it means whatever comes out of the cannon in this animation, it will hit the ground at 30 meters. So let's see if we were right. So here is the animation, and I will move this target to 30 meters. So it should be 30 meters. Let me set it to 30 meters. Yes. So if our calculation is right, whatever comes out of the cannon, it will hit this circular target, because we have just calculated that if the velocity, initial velocity is 21 meter per second, and it's purely horizontal at the beginning, and height is 10 meter from the ground, the whatever comes out of the cannon, it will hit the circular target at 30 meters. So let's see if we are right. Yes, so our calculation was right. It has hit the circular target at 30 meters from the beginning. The next quantity we calculated was the time, right? The time it will take for the projectile to hit the ground, and this time was 1.43 seconds. So in the animation I have this tool, I can put it there, and it will tell me the time it has taken for the projectile to, and sorry, not the projectile, actually it is a projectile, but it is another form of projectile. So yes, I can see the time, it's 1.43 seconds. You see in the top one box is showing the time it has taken for the thing which comes out of the cannon, and the total time is 1.43 seconds. So we were once again right. Unfortunately, this animation doesn't give us the option to calculate the final velocity when it will hit the ground. But I can turn on the velocity vectors, and you can see the arrows velocity vectors along with the motion of this body. And it will give you some information about the motion. It will not give you the value of the final velocity when it will hit the ground, but you will get some idea what happens to the velocity vectors during the motion. So this time I will play it slow, and here is the velocity vector. So you see at the very beginning the velocity vector is purely horizontal, and then you see that velocity vector is divided into two components, horizontal and vertical. And because gravity is working on it, so it will not go a straight path after coming out of the cannon. In fact, it will follow a curved path like this. So one thing I want you to consider in this animation, you see the horizontal component, and then there is a vertical component, and I will go in simple steps, and you see that vertical component is increasing, vertical component of the velocity is increasing, But keep an eye on the horizontal component of the velocity. It will remain the same. In fact, it must remain the same throughout the motion of this body, because I told you in the lecture that the horizontal component will always be the same. And if you remember, when we were calculating the final velocity when it will hit the ground, we calculated the vertical component of the velocity, but we just took the initial horizontal component of the velocity as the final horizontal component of the velocity, because I told you that the horizontal component of the velocity will never change throughout the motion. So now I am going in small steps, and you see that horizontal component is not changing, but vertical component is changing. So now when it will hit the ground, you see that horizontal component is still the same because it didn't change, but vertical component was of course changing, and that's why we use the equations of motion to calculate this vertical component, and then we reconstructed the velocity vector with which it will hit the ground, and we also calculated the magnitude of that vector.